So we just got through working on our 45, 45, 90 triangle, which is just a very common triangle in math. Another common triangle you see a lot is a 30, 60, 90. So we're going to use an equilateral triangle to show how the lengths of the short leg, long leg, we know about those in right triangles, and the hypotenuse of a 30, 60, 90 triangle are related. So what do we know about equilateral triangles? Well, to start, we know that they have three congruent angles. So if we take this equilateral triangle and we draw in the altitude, and I'm just going to draw it in from the top vertex, that's going to come straight down and it's going to create a right angle. Now I have two right triangles. And I should have said this before I drew that in, but we can talk about it now. These angles that are equal all have to add up to 180. So if you take 180 and divide by 3, each angle in the equilateral triangle is 60 degrees. Then we draw in an altitude straight down. That is going to bisect the angle up here, and that gives us a 30-degree angle. So here is a 30, 60, 90 right triangle. So let's talk about side lengths of equilateral triangles. All three sides are congruent. So what we're going to do is we are going to talk about the short leg of this right triangle. The short leg is always opposite our 30-degree angle. Every single time, it's always across the triangle. There's our short leg. We're going to go ahead and call that X. X is going to represent our short leg. Well, when this altitude comes in our equilateral triangle, it does bisect this side. So this side over here is also an X. How long is this whole side of our equilateral triangle? It's an X and another X. So this whole thing is 2X. So I know that this side of the equilateral triangle is 2X, and I know that this side is 2X. So what we have right now, if I were to redraw this triangle over here, just to kind of show what we're focusing on, here's our 60, here's our 30. The short leg is an X. The hypotenuse across from our 90 we saw right here is 2X. Well, now we know that the hypotenuse is always twice as long as the short leg. That's the relationship between the short leg and the hypotenuse. So what about the long leg of this right triangle? Well, why don't we go ahead and use Pythagorean theorem and solve for it. Let's figure out what it is. That will help us see the relationship. So a squared plus b squared equals c squared. We'll let x be our a plus, now I don't have vertices labeled, so I am going to call this side over here LL. Super creative. That stands for long leg. That gets squared and it equals our hypotenuse, 2x squared. So let's go through and square everything. We have an x squared plus our long leg squared equals 2x squared is 2x times 2x, so we get 4x squared. We do want to solve for our long leg, so let's get this x squared to the other side. We can do that by subtracting x squared. So our long leg squared equals 3x squared. Now to have just the long leg, we're going to undo the square by square rooting both sides. So the long leg of our 30, 60, 90 triangle is equal to the square root of 3x squared. So we're going to square root the 3 and square root the x squared. 3 is not a perfect square, and we cannot reduce it with a perfect square, so that's going to stay underneath our radical. But we can square root the x squared. Square root of x squared is x, and that 3 stays underneath. That's a little sloppy, but what we just discovered is that the long leg of our triangle is x times a square root of 3. So it is the short leg times a root 3. So your short leg is x, the long leg is 2 times x, 2 times the short leg, or hypotenuse. What did I just call this? The hypotenuse is 2 times the short leg, and the long leg is square root of 3 times the short leg. That's how they're all related. All right, so let's put that in a definition. In a 30, 60, 90 degree triangle, the length of the hypotenuse I'm just going to abbreviate that HYP, H-Y-P. Length of the hypotenuse is twice the length of the short leg and the length of the long leg is square root of 3 times the length of the short leg. Not a lot of room to write that in, huh? Okay, so if you have a right triangle ABC where angle A is 30 degrees, angle C is 60 degrees. So if you have a right triangle, a 30, 60, 90 right triangle, with short leg across from the 30 as x, then that means that AC, our hypotenuse, is 2 times the short leg, and AB, our long leg, is root 3 times the short leg. So we write it as x times a root 3. Okay, let's put this into practice. We've got a few examples. We're going to find our missing sides of this triangle. We recognize it's a 30, 60, 90, and we know that the across from the 30 is the short leg. So our short leg is 6. The hypotenuse is twice as long, so 2 times 6 is 12. The long leg is root 3 times the short leg, so 6 times a root 3. We have all 3 sides. All right, part B, we have a 30, 60, 90. We don't know the short leg, but we have the long leg right here. Remember, the long leg is equal to the short leg x times a root 3. And we can see that the long leg is 9 root 3, and those are the same measurement. So do you see how the short leg must be a 9? So we know our short leg is 9, and the hypotenuse is twice as long as the short leg. So 9 times 2 is 18. All right, find the missing sides. So 30, 60, 90 triangle. We know the long leg is 5. So remember, the long leg is short leg times root 3. We know that's a 5, so let's go ahead and set that equal to 5, and now we can solve an equation. We'll just divide by root 3. So x equals 5 over root 3, but we have to rationalize that. Multiply the top and the bottom by a root 3. That gives us 5 root 3 over 3. So our short leg x is a 5 root 3 over 3. So if we go on the picture, here's our 30 degrees. Opposite of that is the short leg, so this is 5 root 3 over 3. Now the hypotenuse is twice as long as this. So if I multiply 2 times a 5 root 3 over 3, that's like a 2 over 1. That 2 just multiplies with that 5. And we get 10 root 3 over 3. All right, last one, 30, 60, 90 right triangle. We don't know the short leg, but we do know the hypotenuse. Hypotenuse is twice as long as the short leg. So if the hypotenuse is 14, the short leg must be 7. And the long leg is root 3 times the short leg, so 7 root 3.